So there's a formula for the radius of a sphere. It comes actually from the volume of the sphere formula. And if we rearrange it, we end up with the radius is equal to the cube root of 3 times the volume divided by 4 pi. So if the volume is 200 pi over 3 units cubed, how do we find the radius? Well, we have the volume part of this formula, so we just need to plug it in and simplify it. So the radius is equal to 3 times, well, my volume expression is this. So I'm going to replace the volume with 200 pi over 3. And this is where the working with complex fractions is very useful. It's good to understand how to simplify complex fractions. And remember that with a fraction, there's only times and divide. There's only a numerator and denominator. As long as you know which, if it goes in the numerator or denominator, we can simplify these things fairly easily. So here I have a times 3. This is a divide 3. These cancel out. Okay, this pi is in the numerator. It's a times pi. That's a divide by pi. Those cancel out. That's times 200. That's in the numerator. That's divide by 4. That's in the denominator. So I just write it like this. There are no perfect cubes in 50, so when my radius then is going to be the cube root of 50. Now some of you who know the volume formula for the sphere, the volume of a sphere is equal to 4 pi over 3 r cubed. We can solve this algebraically for r as well, and we get the same value. Okay, so if you can see that we can divide both sides by pi, times both sides by 3. I can undo that times 4 with a divide 4, and I end up with 50 equals r cubed, and then undo the cube with a cube root, and I get the same value. Here we have a coordinate geometry problem. We have some coordinates here. We have a coordinate at 3x, negative 4, x root 3. We don't know what x is, but we know that this is 3 times the length of that. And we know that these make one side of a square, and the area given is that unit squared. Okay, well, let's set this up. So I'm just going to arbitrarily say that that's going to be x, so that would be about 3x here. Okay, and then I know that one of my coordinates is going to be at negative 4, so I'm going to draw negative 4 down here, so 3x negative 4, that would be one coordinate, and x root 3, so that's 1, 2, root 3 is about 1.7, so we'll say that that is about root 3, about there. Okay, so this makes one side of a square, so this line is one edge of a square, so we know that the area of the square that we make with this one edge, that area is equal to, I'm just going to shape that in, this area, this square area, is equal to that. Okay, so we can essentially just use Pythagoras here, really, because we know that if we can work out the side length expression, we know that a squared plus b squared equals c squared. So the length of this side here, if I take a look at these positions, we can find the displacement or length by subtraction. So we know that 3x minus x, that length is 2x. In fact, I'm going to write it as a displacement. 3x minus x, which is equal to 2x. And the vertical length here, well, we know this is going to be, we just subtract those, so we can go root 3 minus 4, negative 4. So we get root 3 minus negative 4. So if I want to find the distance in the coordinate plane, I subtract. So that distance here is going to be equal to root 3 plus 4. And I know that a squared plus b squared should give me c squared. So I know I'm going to write this in: a squared plus b squared equals c squared. Okay, and that's actually c the square, so I can just use that value for c squared. So I'm just going to say c squared is 31 plus 8 root 3. I'm going to write an expression for x on this side. So a squared is going to be root 3 plus 4 squared plus 2x squared. And now I have an equation which I can solve for x. So I drew a picture, just get an idea what this looks like. I generated a relationship. My relationship that I'm using is a Pythagoras relationship. Okay, some of you may use Pythagoras to find the black line and then square it to get the area, but I just said that I kind of skipped a step in that case, because I just said, well, I know that this square area is the area that when we add up a squared and b squared. Okay, so then I just need to work this out and solve for x. Okay, so I'm going to square this out. So I'm going to end up with root 3 times root 3. 4 times root 3 plus 4 times root 3 is 8 root 3. 4 times 4 is 16. And then 2x squared is 4x squared. And we get 31 plus 8 root 3. We have 0 pairs there on both sides. Combine like terms. In fact, I'm just going to solve for x. So I get 4x squared. I'm going to subtract 19 from both sides. So I'm going to be left with 12. Okay, I think that's right. Minus 3 minus 16. Minus 3 minus 16 is going to give me 12. Divide both sides. And I get x is equal to plus minus square root 3 when I solve for x. Remember the plus minus. Now, because x is a coordinate, x can be negative. Okay, we could have drawn the picture x going to the right. We could have also drawn x going to the left. It would have given us the same square. So our x value we have to keep as plus and minus root 3. Okay, and the reason why is because the way the problem set out is x is a coordinate, not a length. That's different. If x was a length, we can only use a positive. But since x is a coordinate or a position on the number line, it could be on this side, it could have been on the other side, and we could have had the same solution.